Hello, everyone. So we have another AMC 12 problem. So this was a number 20, uh, I guess. And then this is a complex number. Actually, this was a 21. So this is a imaginary number, right? We are given, which is like complex number anyway. Um, so what we want is based on the given z, we want to like multiply these guys. Like when you see the problem itself, it looks like too tedious because we have a lot of like huge powers, and then the z is itself is not nice looking. So, but in most cases, when you take some power of like these kind of like complex numbers, you actually end up getting something nicer. So let's go ahead and do that. So if I take the z to the second power, so when you square the numerator, so you get 1 plus I squared, which is going to be by square of binomial 1 plus 2I plus I squared over the square of this will be just 2. So the I squared is -1. This is also 1. So these guys add up to 0. So 2I over 2 is just I, which is nicer, as I mentioned. So then if I square this, which is going to be I to the second power, because z squared is I, so z to the fourth will be just I squared, which is equal to -1. And if I take the another square of this, so z to the fourth to the second power will be z to the eighth, so the eighth power of this. The reason I'm just taking the square because that will make this number to be 1. So when you kind of have a power of like complex numbers getting 1, so that means you're cycling side usually. So if I take the z to the 9, for example, so this is equal to z to the 8 times z to the first, right? So z to the 8 is 1, so which means any power that is like multiple of 8, so you can just write as like product of two complex number with the one power is multiple of 8, the other one is just whatever left over, so which will be useful. So for example, the first one, like we have 1 square, right? So 1 square is just 1, so z to the 1 is just 1 z. So that's the first one. And the second one, z to the fourth power, z to the fourth power is right here, is -1. So I'm going to just write it -1. And then the next one is 3 to the 9th power, which I did right here. So that will be z to the 8 is just 1 times z is going to be z, right? So that means z to the 9th will be just z. And if I go with the z to the 4th square, which is z to the 16, 16 is a multiple of 8, which means you actually take the square of 1. So that needs to be just 1. And we just got now 1. So z, -1, z, and +1. So it looks like we have this pattern. So let's double check. Like we expect to get z next time. So the next power will be z to the 5 square, which is z to the 25, right? So this is z to the 24 times z to the first. Z to the 24 is 1 because z to the 8 was 1. So if you take the third power of this, you got 24th power of z, which is 1. 1 times z is just z, which we were expecting. So meaning that our cycle for the first parenthesis is going to be this. But we have 1, 2, 3, all the way to the 12, which means there is like 12 terms right here. So let me write this. If you kind of keep writing the rest, you can see that. So we have cycle of 4, and then in total 12 terms, which means we have 3 of this guy's sum. So this guy and this guy add up to 0. So z and z is 2z. And then the total was like 3 copies of this, which is going to be 6z. Okay, so let's keep this in mind. And the next one is not different, so it's just the fraction part. So 1 over like z for the first one. And then this is z to the second power. So z to the, z to the like 2 square is z to the fourth power. So z to the fourth was -1, so which means this will be 1 over -1. So that should be just -1. And the next one is z to the 3 square. So 3 square is 9. So z to the 9 was z. So which means the third term is going to be 1 over z, which is same as this guy. And the next one will be 1 over 4 to the second power, which is 1 over 16. So 1 over 8, like z to the 8 is 1. So 1 over 6, z to the 8, 16 power. So maybe I can write it here. So 1 over z to the 16 is actually same as 1 over z to the 8 to the second power, but we know that z to the 8 is 1, so square is also 1, so 1 over 1 is 1. So we have like 1 over z, negative 1, 1 over z, and 1. So now we have cycle of these 4. And if you are not convinced, you can just keep writing a few more just to see if you are actually getting what you expect. So what we expect as our next term is 1 over z, right? So because that was our first term in this cycle. So then these guys add up to like 0. So 1 over z, 1 over z is 2 over z, but we have these four like four terms of cycle 3 times because 1 through 12 square. So which means 3 times 2z, 2 over z, which will be 6 over z as well. So they cancel z's. So you will end up getting 36. So you can use this problem like a lot of different ways. You can use like exponential form or some other like tools that we have with the complex number, but sometimes don't try too much. I think just taking some like powers and see if there is like nice relation or cycling. So that might be useful. In this question, it was the case. So even though this was number 21. So I'll see you in the next video.